Welcome back, everybody. We're going to continue section 4.4, talking about if something is a factor or not. So I'm going to jump down here. Factors. Factors are numbers that we can multiply together to make a product. So factors of 24 can be 3 and 8, 1 and 24, 2 and 12, 6 and 4. So if I use the 3 and the 8, 3 is a factor of 24 because I can multiply 3 by 8 to get 24. So if we're asking in polynomials if something is a factor, we're trying to find out, is that a 0, x-intercept, root, or solution to the polynomial, or can it help us get there? The biggest reminder in this entire part is that our answer or our remainder, depending on which method you pick, always has to be a 0. Always, always, always has to be a 0. Always, always, always. Your remainder or your answer, depending on which type that you choose to do for a method, has to be a 0 every single time. So, the first way to determine if something is a factor is to plug it in. So we are going to take our 2. Remember, when I'm looking at x minus 2, x's are liars, so we would use positive 2. And we are going to substitute positive 2 in for x in our equation. If our answer is 0, then x minus 2 is a factor. If it doesn't equal 0, then it's not a factor. So let's try it. We're going to plug in 2. We get 2 squared minus 2 times 2 minus 4. 2 squared is 4. 2 times 2 is 4. Oops, that's a plus, sorry. And then minus 4. 4 plus 4 minus 4 gives us an answer of 4. Well, 4 is not a 0, so x minus 2 is not a factor. And if it's not a factor, then we can't continue further with anything else that we'll be asked to do with our polynomials. Another way, and a way that will always work, is to use division. We can use long division or shortcut division, depending on what we're given as a potential factor. So we're looking at this and saying, is x plus 5 a factor of this polynomial? And remember, our remainder must be 0 to say yes. We can use long division. Check to see, is this in standard form? Yes, it is. Is it missing a factor? Or, I'm sorry, a term? Yes, it is. It's missing x to the first power. Now remember, when we're doing long division, you don't really have to add in that 0, but it is a great placeholder. And so we encourage you to go ahead and make sure you add that in. The other method that we could do for this is the synthetic or shortcut division, because this is just single x to the first power. And so for this division, we'd be starting with negative 5, 3, 15, negative 1, 0. So we have 3 that we're dropping down. Times 3 is negative 15. 15 minus 15 is 0. Negative 5 times 0 is 0. Negative 1 plus 1. Negative 5 times negative 1 is 0 plus 5 is 5. And negative 5 times negative 25 and negative 25 is 0. So that's exactly what we were looking for. This is our 0 remainder. That means that x plus 5 is a factor. X plus 5 will help us solve the polynomial, and it is going to be a 0 root solution or an x-intercept. Just to review the long division over here real quick, remember we always start with those first x to the 4th divided by x, which is distributing the 3x cubed. We have 3x plus 15x to the 3rd. Subtracting, they both bring down both the negative x squared and the 0x. Negative x divided by x is x. Distribute our negative x. We have negative x squared minus 5x. Subtracting. I'm going to go ahead and distribute that negative 1. Add to 0. 0 plus 5 is x. Bring down that positive 25. 5x, divided by x gives us positive 5. 5 times 5 is positive 5. And then we are subtracting, and that all subtracts to 0. So 0 remainder again. 2 ways to decide if it's a factor or not. So the answer to this is yes. So to bring all this together, working on one step closer to our end game of graphing these polynomials, we want to show or check is x plus a factor of this polynomial. If it is, then we factor the answer completely. So you can use either method. Also, because we want to go ahead and factor further, we will want to make sure that we use the division method. It's not going to tell us what's left over from that factor to factor further. I'm going to go ahead and use our shortcut or synthetic division. Checking this in standard form, but it is missing x squared. So I'm going to add in x squared to this. So for negative 3, we have 1, 0, negative 1, negative 3. Bring down the 1. Negative 3 times 1. 3 minus 3 is 0. Negative 3 times 0 is 0. 0 plus 0 is 0. Negative 3 times 0 is 0. Negative 1 plus 0 is negative 1. Negative 3 times negative 3. Negative 3 plus 3 is 0. So here's our ever important 0 remainder saying that x plus 3 is a factor. Now we take answer that we got from this division problem and factor it further if we can. Fill in my x values, x to the first, x to the second, x cubed. And so that answer is x cubed minus 1. X cubed minus 1. Well, this is a difference of squares formula. I'm sorry, a difference of cubes formula. Because 1 is a perfect everything, and the x to the third is that clue. So that tells me that my a is x and my b is 1. So we have a squared plus a times b plus b squared. And then our x plus 3 from the start of the problem. So these are the factors of the polynomial that they gave us. Now we're going to check x minus 2. So again, I'm going to look to see, is this in standard form? It is, but it is missing x squared. So I'm going to go ahead and add in that 0x squared because I'm going to use the synthetic or the shortcut. I'm using positive 2, 1, negative 2, 0, 1, negative 2. Bring down this first 1. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 0. 2 times 0 is 0. 1 plus 0 is 1. 2 times 1 is 2. And negative 2 plus 2 is 0. Again, your remainder saying yes, x minus 2 is one of my factors. Fill in my variables so we can factor our answer further. And so I have cubed plus 1 is what it becomes. So that x to the third power says, oh, this must be a sum of cubes formula. 1 is a perfect everything. So we know that 1 cubed is 1. So our a is x and our b is 1. Using our formula, a plus b, a squared minus a, oops, I'm writing a instead of x, plus b squared. And then bring down that original x minus 2, and this is the factored form of this polynomial. Those are all the values that multiply together to that polynomial. This ends our section 4.4. See you tomorrow.